Memory is one of the most misunderstood parts of AI agents. People hear memory and imagine the model magically remembers everything forever. That is not how serious systems work. Without memory, an agent forgets context and keeps restarting from zero. With bad memory, it remembers the wrong things, drags stale facts forward, and can make confident but harmful decisions. So memory is not a magic feature, it is a design choice. In this lesson, I will show the difference between short-term and long-term memory, explain episodic, semantic, and tool memory, and show why strong memory design matters just as much as model quality. By the end, you should be able to look at an agent and ask a senior level question. What does this system remember? Why does it remember it? And what can go wrong if that memory is wrong? Memory solves a very practical problem. Real users do not restate everything on every turn. They say things like, use my usual deployment style, or do the same rollout pattern as last time. For an agent, that only works if the system can recover the right context. Maybe the usual style means blue-green deployment, AWS infrastructure, EKS workloads, and GitHub actions for delivery. Without memory, the agent has to ask again or guess. And guessing is dangerous in engineering. So the point of memory is continuity. It carries the right context from one step to the next, or from one session to another, without pretending the model has perfect recall. The key word there is right. Good memory does not store everything. It stores information that is useful, safe, and relevant to the current decision. Once we say memory clearly, we can separate the types. Short-term memory is the working context for the current task, recent messages, the current goal, and the last few tool results. Long-term memory is saved information across sessions, such as a user's stable preferences. Episodic memory is about past experiences or past actions. For example, last time the deployment failed because a secret was missing. Semantic memory is stored factual knowledge about the user, team, or system, like the team uses PostgreSQL or the main cluster runs on EKS. Tool memory is remembered tool output, such as the last API response or the deployment ID returned earlier in the run. These types matter because they answer different questions. What is happening right now? What does this user usually prefer? What happened before? What stable fact should guide the answer? What tool result do we still need? If you mix those together carelessly, the agent starts using the wrong memory for the wrong job. Short-term memory is usually the easiest place to understand this. Imagine the user says, deploy this app. The agent asks, which environment? The user says, staging. From that point on, the agent should remember environment equals staging for the rest of the task. That means when it checks logs, reads deployment status, or prepares a rollout plan, it stays anchored to staging instead of asking the same question again. This is working memory. It lives close to the conversation and it should usually expire when the task ends. Senior teams keep short-term memory tight because it is supposed to help the current run, not become a permanent biography. If you stuff too much into this layer, the agent gets noisy. If you lose this layer, the agent becomes repetitive and brittle. Long-term memory is different because it survives beyond the current task. Suppose a user consistently works on AWS, prefers EKS for Kubernetes, writes most services in Python, and uses GitHub actions for CI and CD. Those are not just random details from one chat. They are stable preferences that can help future runs start faster and stay aligned. So when the next request comes in, the agent can lean toward AWS examples, EKS deployment patterns, Python code samples, and GitHub Actions workflows unless the user says otherwise. That is useful, but it also needs discipline. Long-term memory should favor stable preferences, durable facts, and user-approved defaults. It should not blindly carry temporary choices forever. If the team moved from GitHub Actions to another pipeline 6 months ago, stale long-term memory becomes a source of error, not efficiency. A common beginner mistake is dumping everything into memory and calling that intelligence. That usually breaks fast. First, you store wrong information because not every statement is stable or true. Second, you create privacy problems because agents may retain details they should never keep. Third, you add irrelevant context, which makes retrieval worse instead of better. Fourth, you increase token cost because bloated memory has to be searched, filtered, or injected back into prompts. And fifth, you confuse the model because old and new facts start competing. In production, bad memory design can be worse than no memory at all. A stale secret workaround, an outdated deployment policy, or a remembered but revoked preference can push the agent in the wrong direction. More memory is not automatically better. Better memory is better. This is why senior engineers treat memory as a database design problem, not a magic prompt trick. They ask, what exactly should be remembered? Who owns that memory? When should it expire? Can the user edit or delete it? Is it sensitive? Should it be applied automatically or only when requested? And how do we prevent stale memory from quietly shaping future answers? The architecture usually looks like this. Conversation context flows into a memory extractor. The extractor decides whether anything is worth saving. That goes into a memory store with metadata like type, owner, timestamp, sensitivity, and confidence. Then a retrieval layer decides what is relevant for the current task and returns only those memories to the agent. Not everything comes back. Only the relevant memories do. That retrieval step is critical. Memory systems fail when storage is easy, but retrieval is sloppy. The right design remembers the small set of facts that help the next decision and leaves the rest out. So here is the senior level takeaway. Agent memory is not about remembering everything. It is about remembering the right things at the right time. Keep short-term memory close to the active task. Keep long-term memory focused on stable, useful preferences and facts. Store past experiences carefully. Treat tool results as temporary evidence, not eternal truth. And design retrieval so the agent sees only what matters now. If you get that right, memory makes agents feel consistent and practical. If you get it wrong, memory becomes a source of drift, leakage, and false confidence. In the next lesson, we can take this one step further and build a simple agent using Python and langgraph so you can see how tools, memory, and controlled workflows fit together in a real implementation. At TrustScreen, we are building tools around this problem, and I will show more in future videos.